Thank you very much, Thomas. And yes, we have now time for a little bit of Q&A. Let's say we will continue with the next presentations in about 5 minutes from now. So in case someone doesn't need to hear the Q&A and needs to get a coffee or something like that, then feel free to come back in 5 minutes, and if you want to see the remaining presentations. I have some questions here, maybe a first one that I can directly address, which is related to the radially fibered keyword. Actually, here someone was asking about radially fibered meshing does not result in a bad mesh at the tips or a skewed mesh. Maybe let me clarify that. So we're not talking about the radially fibered meshing, but we are talking about the radially fibered geometry. So it's the way the blade is generated, which, as I explained, means that we align the camber surface of the blade in the direction of the centrifugal forces, so that we have better strength with regard to these forces, but it's not related to the meshing of the blade or the meshing of around the blade. So there is no issue there with the mesh that in some way results from the radially fibered construction. We have a question here to Mr. Hildebrand specifically. For the geometry optimization, will NUMECA communicate and invoke cases to reconstruct the geometry, or will it work on curves inside NUMECA? I could also answer something, but maybe you'll take it. And then
No.
There's a follow-up question, maybe about the optimization process. How are the parameters filtered with regard to non-significant parameters versus more significant parameters for the optimization results?
Okay, let's start with number one. We are using cases as the geometry generator inside the optimization. So we have own geometry generators, but in that case, because of the flexibility and also the volume generation, cases was addressed by Fine Design 3D, which is our optimizer, in order to change the parameters. Number two is about filtering insignificant results.
Right, or parameters. Basically, I think it's more something related to do you take a look at the sensitivity of the objective with regard to different parameters, and do you maybe exclude some parameters that are not so significant versus
we're doing that. So we run a sensitivity study and also an ANOVA analysis, and you can clearly see the impact of several parameters. The downside is not the downside, but it's inherent in the process that you have to run quite a number of shots in order to get a sensitivity already. So in the beginning, yes, you include insignificant parameters, which you can exclude later. That's possible.
Yeah, definitely makes sense. Thank you. There is a quick question that I can address, which is related to modeling overlapping fillets at the turbine blades. So actually, this was a situation. In principle, of course, you can also model overlapping fillets. There were some issues with the robustness of the geometry when we get fillets that overlap each other for neighboring blades. That's why here we integrated this process of making sure that the fillets do not intersect, so we have a very robust setup, and we get the maximum that we can get without intersecting. I don't know if there are other issues. This was one specific issue that other issues that might be related to that. But yes. And there is maybe final question before we continue with the other presentations, which is related to surface roughness. Maybe this is something that our colleagues here from Rolls-Royce Solutions might be able to say something about. What is the impact of surface roughness, e.g. to compare additive manufacturing versus a machine surface? Is this something you have any experience with or could say something about?
The surface roughness of machined impeller for the compressor, so I can say it for the compressor side at least, is for sure better than a printed compressor. Yeah. Mm-hmm. But we didn't, in the calculations, we didn't take into account surface roughness, because for our machines it was not of any significance.
Do you have any kind of experience with additive manufacturing created impellers? If it might have an influence because it's a rougher surface and maybe it's not so good, or is this not something that you have tried so far, let's say, or measured at least so far?
This is a question perhaps Nico can better answer, because he's nearer to this 3D printing topic.
Yes, maybe I can say something to that. So on the turbine side, we have some experience with different manufacturing methods. So we have the fine casting process that we usually use in a series production, but in the prototyping phase, we use also different manufacturing processes, such as a milling process or additive manufacturing process. Mm-hmm. And it looks a lot like for our turbine sizes, the different surface roughnesses don't play a vital role. It might be different for smaller turbines, I guess, maybe for automotive turbines, but the roughness is very, very small compared to the overall size of the turbine, and we didn't find or measure significant difference between different manufacturing techniques up to this point.
All right. Yeah, thank you. Very, very good. Thank you for these answers. So let's finish this Q&A session and continue with our agenda, so that we were able to cover everything that we need in the time that we have. So I would like now to invite our next presenter, which is Johannes Ratz from IHI now, Technical University Darmstadt at the time of the project, and he will tell us something about the optimization of the compressor side of the turbocharger. So let me make you the presenter.